Hi, in this video we're going to find the perimeter of a more complex shape that involves right angled triangles, copied. Now, we've got this right angled triangle here, and this figure down here consists of 5 equal copies, congruent copies of that particular triangle, and we want to find the perimeter. Now, if we look at the perimeter here, we can see that we've got these lengths here like this, and that is equal to that length on this triangle here. So we need to work out that. But we've also got this kind of shorter length here. Now, how do we find that length? Well, can you see that if you've got the shorter length of the triangle, then you could subtract this short length of the triangle from this hypotenuse of the triangle to find the yellow length. So in short, basically, we need to find all 3 lengths of this particular triangle and then use it to find the yellow length and the purple length and then duplicate appropriately. So now we're not actually given any angles on this triangle other than the 90 degrees. So we need to work that out. But let's look. We can see that in the center here, the total angle around that point is 360 degrees. And because all these triangles are the same triangle, we can just divide the 360 by 5 to give what each angle at the center is. So we can see each of these angles is 72, so that angle there. So this angle here is 72 degrees. And now we've got enough information to work out the 3 side lengths of this. So let's just do it up here. Remember, we label the side lengths of this triangle relative to this angle of interest. So the angle of the interest is just the angle that's given that's not the right angle. So we're trying to find, well, all the sides really, but we know this side, the 7, so we label that as h because h is the hypotenuse, the longest length of the triangle. And let's just say we're trying to find the purple length first. This purple length here, that is opposite the angle of interest, so it's opposite over opposite. And then we can just use SOHCAHTOA, our mnemonic, for working out which trigonometric ratio to use, SOHCAHTOA. Now we're using the O and the H here, so it's this one here, which is the sine. And remember, that was short for sine of the angle of interest, that's a Greek letter theta, often used for angles, is equal to O over H. So this is the angle of interest down here, the 72. So we substitute in sine of the 72 is the opposite, which is, we don't know, let's call it x. So x over the hypotenuse, which is 7. And then we just need to multiply both sides by 7. So x is 7 sine 72, which is equal to 6.6574. That'll do. So we've got that. We've got this side length is 6.6574. And now we could find this other side length using trigonometry again, or because we already know 2 of the side lengths of this triangle, we could use Pythagoras theorem to find the 3rd length. So let's just copy this triangle down here. So I've given myself more space. We're given, we know the vertical is 6.6574. And we know that the hypotenuse is 7. And we're trying to find this length at the bottom. Let's just call it y. Remember how we labelled sides for Pythagoras theorem? We label the 2 shorter sides as a and b, either way around, and the longest side, the hypotenuse, as c. And Pythagoras theorem is that a squared plus b squared is equal to c squared. So got that. Just substitute in. So a is y squared plus the b squared, which is the 6.6574 squared, is equal to the c squared, so the 7 squared. And then we can just subtract this. And then to get rid of the squared on the y, we square root it. So square root of 7 squared minus that previous answer squared. And that gives me y is 2.163. 12. But as I said, you can use trigonometry to get that as well. So, okay, we've got this length is 2.163 1 will do. So just I'm given 4 decimal places. Now we've got everything we need because we know the purple length is 6.6574 in this diagram. And then we know this blue length here is the shortest side, which is 2.1631. But we also know that this whole hypotenuse here of that triangle is 7. So can you see that the yellow length here is just going to be the 7 minus the 2.1631. So let's do that. 7 minus 2.1631 is 4.8369. Okay, right. So we know each yellow length of each purple length. Now, how many do we have of each? We can see in total we've got another purple length here, another purple length here, another purple length here. We've got 5 of that, and we've also got 5 of the yellow ones as well. So basically, we can just do 5 of each of those added together to get the total perimeter. So the total perimeter is going to be 5 lots of 4.8369 plus 5 lots of 6.6574. We could have just added the 2 together first, then times by 5 would have been perfectly fine. So let's do that. 5 lots of that plus 5 lots of 6.6574. And that gives me 57.4715 as a total perimeter. I want it to 1 decimal place, so it's just 57.5. And that is the final answer.